Hello everyone, today let's solve the problem number 76, minimum window substring. So what the question states here, we have to find the smallest substring in the S. So we have been given a string S here. We have to find the smallest substring in the S that contains all the characters of T. It should contain all the characters of T, right? So here in this case ABC is present. We have to find the smallest substring in S that contains all the characters of T, including duplicates. So if the duplicates are found, including duplicates, we need to find all the characters of T, right? That contains all the characters of T, sorry. If no such substring exists, then we have to return the empty string. The answer is unique, right? So if no such substring exists, then we have to return the empty string. This is important. Just keep this in mind, right? So let's come to the first example. The question is simple, right? I hope the question is completely clear. So let's come to the first example here. In this case, here you can clearly see. First, we can consider this window here, ADOBEC. So it consists of A, B, and C here in this case, right? It consists of A, B, and C. But they have asked us to find the smallest substring in the S. So we can consider B and C. There are many windows you can consider that consists of A, B, and C. You can just check for many words that consist of A, B, and C, right? So because T consists of ABC, there are many words of different lengths that will that contains ABC basically. So here this one B, A, and C consists of ABC as well, right? B, A, and C at the last, and this is the smallest substring here, smallest substring in S. So this is the smallest substring in S that consists of all the characters in T, right? So which is of the length 4, you can clearly see B, A, and C, which is of the length 4. So we need to return the smallest substring itself, right? The smallest substring is that contains all the characters of T itself. So in this case, we will return B, A, and C, right? So output will be B, A, and C in this case. So explanation they have clearly mentioned. So I have just given the example ADOBEC, right, which consists of A, B, and C, right? So there are many words in S that consists of A, B, and C. We have to check for all the words that consist of A, B, C, and we have to return the smallest substring that consists of the all the characters that is present in T, A, B, C in S, right? So that's what we need to do. In our case, we got the output B, A, and C here. So the minimum window substring B, A, and C includes A, B, and C from the string T. That's what they have given. That's what we discussed as well. So let's come to the second example here. We have S equals A, T equals A. Output we have been given A. Because we have only one character T in the T, basically that is present in S. So here the entire string S is the window, is the minimum window, because we have only one character in this case, right? So that itself we have in string S as well. So output will be quite obviously A itself, right? So this is fine. So let's come to the third example here. We have the letters 2 A's here. We have to include duplicates as well. They have clearly mentioned in the question. I have read that one twice, right? So we have to include in the S, we should have double A at least, or more than this one characters. If we have more characters, then we have to check for every character that consists of double A. We have to check for every word that consists of double A. In this case, we have only single A. Here in the T, we have double A. This doesn't match at all at any cost. Whatever we do here, S doesn't consist of double A at all, right? So in this case, we have to return empty string. They have mentioned in the question, if we do not find the minimum substring, or if it is not possible, then we have to return this one empty string in that case, right? Both S from T must be included in the window in the explanation. Since the largest window of S has only A, we have to return the empty string, right? They have clearly mentioned. They have given beautiful examples, right? So for us to understand. So I hope the 3 examples that we have discussed is completely clear. Easy to understand, right? Here, this is fine. So I hope the question is completely clear. What we need to do is completely clear as well, right? First, what we'll be doing, we will or let's discuss this one. What do we call approach first, followed by the edge cases one by one, and then let's write the code and discuss the complexities for the code that we have written. Initially, let's discuss the up. So here, first thing that we need to consider here is we are going with the sliding window or 2 pointers approach. We'll be making use of the 2 pointers So we are going with a sliding window approach or two pointers here, right? So I have considered the same first example that they have given in the question so that it will be easier to understand. We have already discussed that one. This one we have to check for all the windows or all the words that consist of ABC. This is one of the examples. So ADOBC consists of ABC. So here in this case, but it is of the length 1, 2, 3, 4, 5, 6 here. In this case, this length is 6. So BANC is the word which consists of only 4, which is of the length 4 basically, and it consists of all the characters in this one T, right? Both consist of all the characters in T, but we have to return the minimum substring, right? So we have to return the smallest substring in S that contains all the characters of T. Sorry, not the minimum substring. Smallest substring in S that consists of all the characters of T. Smallest substring in this case here is BANC, which is of the length 4. Basically, we have to return the smallest substring, nothing but BANC. That is how we got. This is clear, right? I hope this is clear. So let's see the step-by-step execution here. The first step here is we are considering the same first example that they have given in the question, right? So we will we will be considering 2 pointers, right? As we are going with the sliding window, left and right. So we will be going with the left and right pointers. Left to shrink. If many changes are needed, we have to shrink and we have to move the left pointer ahead. To expand from left to right, we'll be making use of the right pointer as usual. Mostly we'll be doing the same thing, right? When we make use of the sliding window or 2 pointers. So this is fine. So we will expand the right. So here in this case, right pointer expands, including first word we find here as that consists of all the letters in T is A, D, O, B, E, C. I have explained this one, right? A, D, O, B, C. A is present, B is present, C is present in this case, right? So this consists of all the T characters that are covered here. All the T characters are covered. This is the word, first word that we find here in this case. So we will start the left contraction, right? So we will, as we have found the word, we will start the left contraction here. So we have to move the left forward, means we have to increment the left. Left moves from A to D. So left moves from A to D here in this case. Left moves from A to D here. So sorry, this one A to D, not this one. Sorry, I just got confused. This one I'm speaking of. Left moves from A to D here. A to D window. Nothing but ADOBC, right? So further when we shrink, we got DOBC, OBEC and BEC. Further when we on shrinking, we got DOBEC. Next when we shrink, we will ignore D. So left pointer will be this one. OBEC we consider. Next when we shrink, this will be BEC, right? So like that, BEC. So these 3 things we get. We go on shrinking, right? So here you can observe, we will not consider this one because A is not present here. In the T, we are having the characters A, B, C. Here, A is not present. So here in this case, BC is present, BC is present, BC is present. We'll ignore this one, right? We'll ignore this one entirely because A is not present. So we will go on doing that. We will go on doing that. We will check for every word by moving the left pointer. I have showed only for the 3 here, including 4, this one. ADOBC and this one, second one, third one, fourth one. We will go on shrinking the this one. What do we call? We will go on this one. Go on with the or move on with the left contraction. We will move the left from this one. Next, after moving from, we will move from D to O, O to B, B to E, then E to C. We'll go on doing that, right? Until we find the smallest substring. So here, when we come, we will be having B, C, O, D, E, B, A, N, C. This one I'm speaking of. So this one, B, E. From here, so let me consider this one. I have already written this one. Here, B, C, O, D, B, A, N, C. Right? This one. In this one, when we go on moving the left pointer, B to E, this one will go on this one. What will we do? So just give me a second. I forgot this one, sorry. So we will start the left contraction and we will move the left pointer from this one. B to E, C to O, then O to D, D to E. We'll keep on moving the left pointer, basically, finding the words. The smallest, this one, substring, that we will find here in this case when we consider B, C, O, D, B, A, and C is nothing but B, A, and C. So this one expands again, then contracts to B, A, and C. So you can check this one. You can just check for every word in this way that I have showed here. The previous previous step, right? So you can just check for every word. But again, I'm telling, when we will do the same thing for B, C, O, D, B, and C, this expands again, then contracts to B, A, and C, which is the valid window. This is the smallest window, or this is the smallest substring in S that contains all the characters of T, right? So T is A, B, C, and here you can clearly see A is present, B is present, C is present as well in this case, right? So A is present, B is present, C is present in this case. So this is the smallest substring in S that contains all the characters of T. So we will return B, A, and C as output. So the output that we got here is, B, A, and C, right? So the output that we got here is B, A, and C, which is equivalent to the output that they have given in the that they have given for the question. I mean example 1 in the question. So the approach works absolutely correct in this case, right? So the approach works absolutely correct in this case, right? So here now we are familiar with the approach. Right? So now let's discuss the edge cases one by one. So the first edge case here is this one, what we call single character match. So this one I'm speaking of. The first edge case here is single character match. You can clearly see we have only one character here. T also we have A. So output will be quite obviously A. Right? So entire S is the window here in this case. So let's move on with the second edge case here. No valid substring. When I say no valid substring here, we have two A's in the T. So we don't have another A in the S at all. This at any cost, this will not be a valid substring, right? We cannot find a valid substring at all, right? At any cost. So output we need to return empty string. They have clearly mentioned in the question. If it is impossible to find this one valid substring, then we have to return this one empty string as output. So we'll return empty string as output. Let's move on with the third edge case here. Already minimum window. When I say already minimum window, we have S equals ABC, T equals ABC as well, right? So output will be ABC in this case. So output will be ABC in this case because S itself is the answer. Both are same here, right? Both are same here. So S itself is the answer here in this case. So we need to return ABC as output. So fourth one, case sensitive scenario. So when I say case sensitive scenario, we have here smaller case and the uppercase. T, we have only the uppercase. We have been given only uppercase to consider here. So we will consider only the capital A from S here in this case. We need to return this one as right. So I hope these four edge cases are completely clear. These are the four edge cases that we need to keep in mind. First thing here is single character match. This one I'm speaking of. Second one is no valid substring. This one I'm speaking of. Third one is already minimum window. This one I'm speaking of. Fourth one is case sensitive scenario. These are the four edge cases that we need to keep in mind. Now we are familiar with the approach as well as the edge cases, right? Now we are familiar with both approach and edge cases. So it will be easier to write the code now, right? So we have to just implement or this one articulate the approach in the form of code, right? Our logical thinking or our thinking process in the form of code, right? So now we are familiar with the approach and edge cases. Let's start writing the code. So the first step here is if S is shorter than T, then no window is possible. We have seen this one in the edge case. We have discussed this one during the example as well, right? So if S is shorter than T, so we were having T double A and then S we considered only single A. So no valid window was possible. That example we considered, right? If S is shorter than T, then no valid window is possible, right? Then we have to return empty string in that case. Let's articulate the same thing in the form of code. I'll just consider simple if condition here. The length of the S here is less than length of the T. Then what we will do? We have to return empty string. They have clearly mentioned in the question that if no window is possible, then we have to return the empty string in that case, right? So this is, I hope this is clear. So the next step here, this is simple one. we are considering the frequency array. Why we are going with the frequency array here? Because we have to track the characters in T. So first we have to track the characters, number of characters in T. So that is the reason we'll be going with the frequency array. So I'll just give here int. So I'll just make use of some variable name. Let's call this one target frequency. So I'll just go with int of 126. This is fine. So next, let's make use of the simple for loop here. So char c individual character, this one we are considering c t 2. Let's consider this one. Let's convert this one to the char array. So this one has to be capital C, right? This one has to be capital C here in this case. So this is fine. So we have to populate the frequency of characters in T. First, we have to populate the frequency of characters in T, number of characters that is present in T. We have to populate the frequency of characters in T, right? So let's increment this one character. So when we find, we are iterating to the individual characters in T, right? So let's increment when we find the characters here. So I'll just give here target this one frequency C. This is fine. Let's increment this one, right? This is fine. So the next step, let's initialize the 2 pointers. Start 2 pointers means left and right pointers. Start, we need the start, and we need minimum length as well, and we need the required characters, nothing but length of the T also we need. So let's initialize these things quickly. So I'll just go with left equals 0, right equals 0, and start, let me initialize this one to 0, and minimum length, let's give this one integer dot, here this one I'll just give max underscore value. This is fine. So the final step here is required chars. This one I'll just give length of the T here in this case. This is fine. This is fine. So next step here is we'll be making use of the while loop, right? So let's make use of the while loop, because right should be less than the length of the s. Because what we are doing here, if you remember, we have to expand the right and check if the character is needed or not, because we have to check for all the words that consist of the characters that is present in T. In our case, in the first example, so we have to check all the words in S that consists of A, B, C, right? So that consists of ABC. If we are considering the words that doesn't consist of ABC as well, but we will ignore that one directly, right? So we'll ignore that one. We will consider all the words that consist of ABC and which doesn't consist of ABC as well, but we will ignore if either A or B or C, the characters that is not present, the characters of T that is not present in the C, then in that case we will ignore that one, right? Finally we will return only the minimum window substring, right? So in this case we have to expand the right and check if the character is needed. Let's go the simple while loop here. While right less than length of the S here in this case, what we will do, so we have to expand the right? So here in this case I'll make use of the if target frequency within the array s dot. So I'll just make use of caret here. In this case we are expanding right, so I'll just give here, let's increment the right here. So this one, let's decrement if it is greater than 0. So we'll expand right and check if the character is needed, right? So this is fine. Next step is we have to decrement the required characters. So we have to decrement the required characters. This is fine, right? So I'll just come out of this one. Not come out of this one. Let's move on with the next step here. So if the valid window is found, we have to try shrinking from left. We saw that one during the approach. If the valid window was found, then we tried shrinking from left. We moved the left pointer step by step, right? So if valid window found, we have to try shrinking from left. One more while loop here in this case, required chars, this one equals 0, then what we'll do, we will update the minimum length and we will update the start index as well. For that, I'll just make use of if condition here. Right minus left is less than min length. This one we can write in this way, right? So I'll just give here min length equals, let's assign the minimum length to right minus left here. This is fine. And also let's assign start to left. I hope this is completely clear. The final step here is we have to remove the leftmost character that we have already considered, we have to remove that leftmost character, right? We have to move to the next one while shrinking. So this one, I can just write that one in this way. If target frequency here s dot char at this one, we have to increment the left pointer here, and we have to remove the leftmost character when greater than 0. This is fine. So required, so I should have copy pasted this one. This is fine. Required characters plus plus, we are incrementing the required characters. This is fine. So the final step here, we need to return the minimum length, right? We need to return the minimum length. So I'll just make use of the this one ternary operator here. This one, just give me a second here. So let's return minimum length equals, so I'll just give here integer dot max underscore value. This lies this one. So here why we are going with the empty string here, because if we do not find the minimum substring, or here even this one here, if the length of the s is less than length of t, in that case, right, then we have to return the this one, what do we call, empty string. They have clearly mentioned in the question. Else, if you have found the this one minimum length or minimum substring, then what we will do, we have to return the substring itself, right? For that one, I can just articulate or implement in the form of code in this way. I'll just give here substring, start substring. So from start to the end means start plus min length. It's fine. Simple to understand, right? So this is it for the code. So let me format the code once and let me hit the run button. So we have went step by step, right? So what happened here? Unknown network error. Please try reloading the page. Just so let me do one thing. Let me hit the run button. So we were having unknown network error, right? Let's see. So now, yeah, you can clearly see here the sample test cases are getting passed. Means let me hit the submit button. Let's see whether this works for all the test cases or not. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct in this case. So whatever the code that we have written works absolutely correct in this case. Let's quickly discuss the complexities for the code that we have written. So here one thing we know here is the approach that we went with here is sliding window. Means sliding window plus 2 pointers, right? Or we can just call this one sliding window. The approach that we went with here is sliding window, and overall time complexity here is big O of this one, m plus n. They have asked in the question to write the code with an big O of m plus n complexity, right? So overall time complexity here is big O of m plus n. You can clearly see here. So in the follow-up, they have asked, could you find an algorithm that runs in big O of m plus n time? They have asked, right? So here in this case, overall time complexity is big O of m plus n. Why it is big O of m plus n here? Because we are iterating s once with right and left. We are iterating this one, what do we call, s with right and left. So this one you can consider, this one you can consider, right? So we are iterating s once with right and left, which is of big O of m complexity, right? And we update the frequency map and big O of 1. We update the frequency map and big O of 1. we will update the frequency map on big of 1. So overall time complexity for that one will be big of n. So total, we got big of m and big of n. Total will be big of m plus 1. So overall time complexity here is big of m plus n in this case, right? So what will be the space complexity here? So the overall space complexity is big of 1. Why it is big of 1 here? So frequency array is fixed here. You can clearly see here. Frequency array is fixed here. Int of 126 I'm speaking of, right? So which is of 128 size, right? Frequency array is fixed. I'm speaking of 128 size. Sorry, this one. So this has to be, I have considered 126 here. 126 works as well. So here basically this is fine. So frequency array is fixed here. This is of 126. And overall this one space complexity would be big of 1, right? Only we have used only few extra variables here. So overall space complexity would be big of 1 in this case, right? So the time complexity is big of m plus n, and the space complexity is big of 1 for the code that we have written. I hope the complexities are clear here. I hope whatever the code that we have written is completely clear as well, right? So for now, this is it. Thanks for watching, guys.